Hi everyone, welcome back to Control Zero. Today, after a few months out, I have prepared an amazing tutorial about the reliability of sensors. And you will learn how the reliability check and reliability merge blocks work, along with some good examples. You will be able to identify when someone cuts the wire of your sensor or unplugs a thermostat, and when this happens, you can notify the Metasys operator by sending an alarm, or you can even execute some custom logic. You will also learn how to set up your sensor's reliability range from CCT and Metasys. And finally, if your sensor goes unreliable or out of range, you can decide to hold its last reliable value, or you can even go to a default value. Alright, so let's get started. Here I have a basic VAB application where I added a few custom activities. And I want to start with the reliability check. So this block has a float input and a Boolean output. And we have three types of reliability checks, but I'm going to be focusing on the float. So this is how it works. If its input is good or reliable, it's going to output a true, a Boolean true. If the input is bad or unreliable, it's just going to output false. So in this case, I have a zone temperature sensor. So let's say that somebody unplugs the sensor or cuts the wire. So I'm just going to do it right now. And notice that when my sensor goes unreliable, my reliability input turns red and my output goes to false, meaning that it's not reliable. Okay, so let me plug my sensor back to the controller. And as soon as it goes back to normal operation, you will see that it will turn back to true, meaning that it's reliable, and it's going to read the original value in a few seconds. And that's basically how the reliability check works. Now I want to show you where you can find this block in CCT. So I'm actually in commissioning mode. I'm going to exit. And if I go to my tools on the left, under the Boolean folder is where you find this reliability check block. And you just drag it over, and that's simple. You can just connect any input, any float input, and any Boolean output, right? And also the reliability merge is right here, that's the one that I'm gonna explain soon, right there. Okay, back in commissioning mode, I want to show you example number 1. And this is an intermediate level tutorial. So I will assume that you know how to do basic connections and add basic blocks. So the first use I have found for this block is executing some logic in CCT. So let's say that my sensor goes unreliable. So it's gonna be not reliable. Here it's gonna go to false, and this not is gonna invert that to true. And notice that we got a Metasys alarm, because this sensor is actually a thermostat and it's SA bus device. I'm gonna acknowledge that. And you will see that it went unreliable, meaning not reliable, false. This get inverted to true, and this true executes some logic. You know, you can always connect something in your execute logic. If it's true, do something, right? So I'm gonna put it back, and we'll wait for our sensor to go back to normal. Return to normal, acknowledge. There you go. Now let's say this is a critical sensor and you want to be notified in Metasys when the sensor goes bad. So what I have created, it's a Boolean to enum translation. So basically, so we don't have false and trues. So what I did, I'm converting my false to an okay and my true to false. So if it's unreliable, it's gonna go to fault. And this goes to this output. And this output, I actually map it in Metasys. Well, what I actually did, in order to auto-discover it, you can make your backnet exposed to true, and you can auto-discover it and map it automatically. Or you can manually map it if you know its identifier information. So let me show you what I have in Metasys. I actually have this window open right here. And here's my point, and I actually have an alarm set up on it. So I'm just gonna enable my alarms. I had them disabled temporarily, so I'm gonna enable my alarm extensions right there. And this sensor is sensor number 1, which is my thermostat. Now I'm gonna unplug my sensor, and notice that as soon as it goes unreliable, there's no way to tell in Metasys unless you have this additional point mapped. Alright, so my thermostat went offline, so I'm gonna acknowledge that. If this was not a thermostat, I wouldn't show offline if it was just a sensor on a regular input. And you can notice that my input went to fault, and we can see an alarm right here. Zone temperature 1 is unreliable. Check thermostat. So you can see that this is pretty handy when you want to monitor critical sensors. I'm just gonna acknowledge that and put my sensor back to normal. And my alarm should go away. There you go. Now let's go to my next example. Here it gets more interesting. Let's say that you have 10 sensors, 10 critical sensors, and you want to know when any of those goes unreliable and you want to send out an alarm. So you don't want to go back and create an additional output per sensor. That's a lot of work. So basically, you can just do an OR. So if this sensor is not reliable, then you can trigger this output to true, and you can map this sensor in Metasys, and we can do the same thing. So let's give it a try. So I'm gonna bring my Metasys window right here, and I'm gonna fail, let's say, my discharge air temperature. Okay, unreliable right away. CCT is always slower, and you can see it's not reliable, so this is true and true, so it gives me this true. By the way, I forgot to enable my alarms, so it's gonna go to enable my alarms, and you'll see the alarm is right there, and you can always add description to your alarm, so that's pretty handy. So my point description says 1 or more sensors fail, and my alarm message check sensors 1, 2, or discharge air temperature. So I can acknowledge that, and I'm gonna fail, let's say, zone temperature number 2, and same thing, you still get the alarm, or the alarm is gonna remain. Sensor unreliable, red, so true. So now let me put everything back to normal. There you go, everything clears. Now on my next topic, I want to show you how CCT knows when a sensor goes unreliable and how you can change those parameters in both CCT and Metasys. Okay, so far we have failed our sensors by suddenly disconnecting them or assuming that the wire was cut. So you see right away that it goes unreliable. But what if we slowly increase the temperature of our sensor? So check this out. Let's change the temperature on sensor number 2 slowly. See, 122, and I'm gonna bring my Metasys window right here. 193 right here, 205, and it's still reliable. So why is that? So 244 and it's still reliable. Okay, 250 unreliable, 260. So now it shows unreliable in CCT. So it had to go all the way to almost 250 to go unreliable. Why is that? So I'm gonna show you really quick where to change that parameter. So if you go back to control and go to your input, you will see that its status is unreliable, it's out of range. So here's the trick. When you add an input, you need to make sure to set up your min and max values correctly. Min value, max value. So you go to edit, and you just gotta put the expected range of that sensor. Let's say we're in Fahrenheit. So if my sensor goes below, let's say 30 degrees and no more than 120, I wanna call it unreliable. So I'm gonna go to apply, and I'm gonna close it. Going back here. So I'm gonna put my sensor back to normal. I'll bring my Metasys window. 118, and now it's reliable. So we know If it goes above 120, it's gonna go unreliable. So let's try that. I'm increasing the temperature slowly. 83. Right here, it's updates faster, 113. As soon as it goes above 120, it's gonna go unreliable. 120 and unreliable. Now, I promised you that I would show you how to do this in Metasys without using CCT. So it's as simple as right-clicking on your point, modify, not command, and in here, you can actually change it. Let's say I want to increase it to 130. So if it goes above 130, it's going to go unreliable. So I'm going to click the check mark and send the command. And now it's back to normal, to reliable. So it is that simple. Now if we look at our JCI thermostat, that comes actually with different ranges for reliability. So it's right here, 32, maximum 104, which those are very good numbers. And you can find them right here. So here's my thermostat, JCI thermostat on my SA bus. So double click on it. And the settings are a little different from my SA bus sensor than my input sensor. So, but the name is the same. It's min value and max value. Those, if your sensor value goes above or below this range, it will be unreliable. All right, so we are ready for our next block, the reliability merge. This block is a little bit more involved. It has a float input and a float output, a number output, not a Boolean output. So this block won't tell you if the input is reliable or not, as in the case of the reliability check. But it also has a second input that is Boolean, and it's called input is reliable. And this is how it works. When my input is reliable is true, it's gonna allow my input to go straight to the output. So let's increase my input. You see that if the value changes on the input, it will also change on the output automatically. But here's a big difference. So in this reliability merge block, you can actually control when you want to consider your input unreliable by just commanding this input to false. So you can add any logic you want. So right now I'm gonna simulate that, I don't know, my logic says that I don't want the input to be, I don't want to consider the input reliable. I'm just gonna simulate that something is telling it that is not reliable, false. So now we have a false, and you can see that my output shows unreliable. But here's the trick. What the reliability merge is gonna do is just gonna keep the value at its last reliable position. So let me drop my temperature. And you can see that it's holding it at the last reliable value, which was 169, just before I switch it to false, right? Now, if my logic decides to have this input reliable, all I have to do is just turn this to true. And you can see as soon as it goes to true, it just allows the value, the current value that is in there. Now let me show you an example of the reliability merge block. Let's say that I want to hold the last value of my zone temperature as soon as it goes unreliable. So we can do a combination of reliability check and reliability merge. So basically the reliability check is gonna detect when the input goes unreliable and is gonna send out a false if it's not reliable. And as we know, if we have a false in the reliability merge, it's just gonna hold its last value. On the contrary, if it's true as of right now, it's just gonna allow the value to go out, right? So let's give it a try. And I'm gonna bring my Metasys window so you can see the value changing. So I'm just gonna drop the temperature suddenly. Oh, negative 379. So you can see that my reliability check, it says, oh, it's not reliable, it's false, so it's just gonna hold it right there. So if I put my value back to normal, let's say 50, 48. It's gonna detect, my reliability check is gonna detect it to be reliable, and now it's gonna let the value go to 45. Now let's unplug the sensor. So you see that it's allowing the value to go through. So I just unplug the sensor and my reliability check is gonna go false. And yeah, it's holding its last reliable value. So let's put everything back to normal. And this is a quick example how you can combine the reliability merge and reliability check. Now for my last example, let's say that you don't want to hold the last value of your sensor when it goes unreliable, but instead you want it to go to a default value. So there are two ways to do this. If you go to your input, gonna double click on it, then go to edit, and you can change this during commissioning. Okay, so here's the trick. Use default if not reliable. So you just gotta make this true. And what's my default is this number. So let's say, yeah, I want to do 70, or let's do 68, for example, and apply. And you can see that my current value is 75.9. So now let's fail my sensor. And you can see that right away it went unreliable, but its value switched to 68. So my current value is 68. Reliability, I guess it shows reliable, but it's saying that it's using the default value and the status is unreliable, out of range. Go to close. And by the way, if I bring Metasys, you can see that in Metasys, it won't show the new default value. It will still show unreliable. Now go to my logic and you can see that in the CCT logic, you can tell that it doesn't even know that it's unreliable. It just gets the default value of 68. Now, if I plug my sensor back, it should go to its normal value. All right, it's getting there, 81. And there it is. Now, let me show you the other way to do this. So I'm just gonna put my sensor back to its original setting. If you go to your logic and actually to your input in the logic, you can change that as well. It's worded a little bit different, but I'll show you. It's called fail soft. So you just gotta turn this to true. Fails. So if it fails, it's gonna go to the default value as well. Let's do this let's put 65. And so these are the logic level. So this applies to any input in your logic. So you can configure any input or even an output to go to a default value. Right there, there's your fail soft and your default value. Now let's go ahead and fail my sensor. And you can see that it goes right away to 65, which is coming from the default 65 in this input, not in your actual sensor. And an interesting thing to note is that if your sensor goes unreliable, it actually holds the last value. So I don't really know if you really need to do the tutorial that we just did, example number 3, because it's still sending out its last value when it goes bad. All right, to finish up, I want to show you a bonus example. Okay, so here I have a reliability check and a multiplexer. So basically, if I have a true in my mode, it's gonna pick input number 2 and it's gonna send it to the output as of right now. So my zone temperature is it reliable? True. Okay, so output that temperature sensor. Now, if my sensor is unreliable, then it's gonna turn to false, and now it's gonna pick input 1, which input 1 is my zone temperature set point. So it will output the set point. So why would you wanna do that? So let me fail the sensor and I'll explain. Okay, so now it's unreliable. So now my actual zone temperature became the set point. So you can see that my set point is the same as my zone temperature. So how can you apply this? Let's say that you are controlling a heating valve based on your zone temperature and suddenly you lose the sensor. So if your valve PID is 25% open and then you lose the sensor, then your sensor is gonna match the actual set point, which means that the PID is gonna say, oh, okay, the temperature is matching my set point, so I'm gonna hold my heating valve at that 25%. So it's a way of holding your valve at its last position when you lose your sensor. So give it a try and let me know if that works for you. So this is the end of my reliability tutorial. It was a bit longer than expected, but I really owed you a good long video. Hope you learned something new and useful, and please like the video and subscribe if you haven't done so. This helps me a lot. Also, please comment below if you have any questions or suggestions, and I'll see you guys on my next video. Thank you very much.